Okay, so Tuesday, last time we were together, we began chapter 7, which is all about exponents and rules of exponents and things like that. And we got 2 rules on Tuesday. Anything to the 0 power is 1 except for one thing. 0. 0 to the 0 power is undefined. Okay. Anything else is 1. Anything to a negative power is 1 over that. Unless it's already in the denominator when we bring it up. I have some examples here, all with 3's. And then we're going to get a new rule today. So, when you are multiplying numbers that have the same base and different exponents, this is essentially what you're doing. Well, if I have 3 to the 4th, that's 3 times 3 times 3 times 3, right? And I have 3 squared, that's 3 times 3. And if I'm multiplying all those 3's together, right? How many 3's am I actually multiplying together? 6. So if I have an exponent, repeated multiplications of an exponent, so this would be 3 to the 6th power. If I have a variable, it works the same way. X squared is x times x. X to the 7th is x times x times x times x times x times x. And one more. How many x's am I multiplying together? 9. So this is x to the 9th power because that's what exponents are. It's repeated multiplication. If I do the same thing with this last one, 2 cubed, 2 times 2 times 2. That takes care of this one. Ooh, I got it again. 2 times 2 times 2. That takes care of this one. And then I got one more 2 to tack on there. And I'd be multiplying all of them together. And how many do I have? 7. Do you see a pattern to what we are doing here? Do you see the relationship between these exponents here and those exponents there? That is our new rule. If the bases are the same and you're multiplying, you add the exponents.
Can we just add exponents and then get it? I was going to ask that earlier.
So that's our new rule. Add the exponents. Now, these two, it's really easy to see. 4 plus 2 gives us our 6 for there. 2 plus 7 gives us our 9 that we have here. But here on this one, I have 3 plus 3. But what's my exponent on this 2 all by itself? 1. If we don't write an exponent, then we have a 1 there. There's actually an exponent of 1. It's not 0. There's an exponent of 1. It's like if I have x by itself. How many x's do I have? I have 1x by itself. An exponent that's not written is an exponent of 1. So I have 3 plus 3 plus 1, and that gives us our 7. So it's really a nice rule. I wrote it down here on the board. If I have the same base, I add the exponents. There's another example of it here. It makes it nice. Questions on this so far? Yeah. Okay. So 12 to the 4th times 12 to the 3rd is 12 to the 7th power. Please do not try to multiply that out on your calculator. It will not work well for you. Trust me on this. It is huge. And you don't want to do it. Okay? Now, on the next one, it doesn't matter if our exponents are negative or positive, we still do the same thing. I have negative 5 to the negative 2 power times negative 5 to the 7th power. That's negative 5 to the negative 2 plus 7, which is negative 5 to the 5th power. It doesn't matter if our exponents are negative or positive, we still just add them together. Okay? Like I said, the rules of exponents are easy. There's going to be a lot of them by the time we get done. And as long as you remember each individual rule and apply them as you should, they're actually a piece of cake. Okay, so we've got 3 rules we've covered here. Multiplying the same base, add the exponents, what to do with a negative exponent, what to do with an exponent of 0. 3 rules that we've covered so far. We will add to that as we keep going. Okay, you have some homework that's like this, or classwork, I should say, that's like this. You got to be careful. That is not 13z to some power. Be careful. Be very careful. When you have coefficients in front, those are not exponents. We only add exponents. We do not add non-exponents. Only exponents get added. These are not exponents. These are just numeric numbers in front. We do to them the same thing that we normally do. 4 times 9. 36. Okay, if it's out in front, if it's a coefficient that's out in front, you just treat it like a regular number and you just multiply them out. However, with our variables, we do add them. What's our new exponent on z? Negative 7. Negative 5 plus 12, negative 7. Okay. What am I not allowed to have in my final answer? Negative exponents. So you will have some problems that are like this. Here's what you do first. Multiply them just like I did here. Do the multiplying and then deal with any negative exponents. Don't do anything with negative exponents until after you've multiplied. Do exactly like this, and then you go, okay, now what do I do? Oh, I got to take care of that negative exponent. Is the negative 7 on the 36? No, it's not attached to the negative 7. The exponent's only attached to the z. That's the only thing. So my 36 does not change, doesn't move or anything. I want to get rid of the negative exponent. What's my rule? I move it to the denominator and make it a positive exponent. My 36 stays there. My z moves down and becomes positive for the exponent. That's what we're working on Tuesday. The only new thing is what to do when we're multiplying. Yeah. We don't have school.
Oh, yeah.
Okay. Same thing on the next one. I have numbers out front, and then I have a bunch of A's. I have no other variables. All I gotta do is worry about the numbers in front and worry about the A's. So I have 2 times 9 times 3. You can multiply them in any order you want. 2 times 3 gives me 6. 6 times 9 is 54. You know the finger trick for multiplying, right? You know how to multiply by 9s? 6 times 9, 1, 2, 3, 4, 5, 6, 54. Works every time. Then I have A to what power?
That's, no, 6.
Remember, this A by itself does have a power of 1. 1 plus 4 plus 2 gives me...
You do realize one of those is a Z, right?
Oh, crap. You're right. No, I didn't. It looked like an A to me. I'm not paying attention. Oh, thank you very much. My bad. My bad. So what is my power by A's?
1.
6.
3. No, for the A's it's 3. Because I have 2 A's. I have an A here. I have an A here. A to the first, A squared gives me 3. My bad. Thank you very much. Not even paying attention.
But wouldn't you just like not even?
Yeah, wouldn't you not be able to multiply?
No. Good questions. It's all multiplication, right? Does it matter order with multiplication? No, I can reorder it any way I want. If all I'm doing is multiplying, I can order it any way I want. If I wanted to, now please don't do this. I'm not asking you to do this. But if I wanted to, I could take this problem and rearrange it to go, okay, I have 2 times 9 times 3, and then I have A to the first times A squared times B to the 4th power, because order doesn't matter with multiplication. I can do it in any order I want if I'm multiplying. So I can take all that stuff, because it's all multiplication, and just flip it around any freaking way I want to do it. I can do that. I don't need to, but we can do that. So then I have the numbers out front. Then I have my A's, and then I have my B's. So you can do it in any order you want, because there's no addition or subtraction. It would be times, because it's still multiplying. So what is my B here? So my A's are cubed, and then I have B to the 4th power. Thanks for catching my mistake while I'm actually recording a lesson. So I really was stupid. It wouldn't be the first time, but won't be the last, I guarantee it. Okay, are we thoroughly confused? Because I screwed up. Okay. So it's really, if you're going to have several problems like this, it's really not hard. Any numbers that are out front, you multiply them together. That's your first thing. If you have a negative, that's a -1. So you would have a negative there. And then you work down through your variables. Okay, I've got an A, I've got another A here. Take care of multiplying them. So you add the exponents on the A's, that's your A's. If you have B's, you do exponents. Oh, I have a B here and a B here. What are my exponents? Add them together. If I have a C, then I do my C's. If I have any variables I have, if I have one that only appears by itself, like here I have the B here. There is no other B, just this B here. That means I have it here. I don't do anything to it. I just smack it on the end. Okay? And one last thing, scientific notation, which I really like scientific notation. Scientific notation was invented for one reason and one reason only. To multiply really ginormous numbers or really teeny tiny numbers, to multiply and divide them. That's all scientific notation is about. By really ginormous numbers, I mean gazillions, distances between planets and moons and stars, and multiplying them together, or really small numbers like distances between parts of an atom. That's all it's for, is to work with really big and really small numbers. That's all scientific notation is. And it's a great, fantastic way of doing it. It's a shortcut. Because technically, what do I have here? I have a 3 followed by 7 zeros. I have a 2 followed by 5 zeros. Do you really want to multiply that out? 500,000 times 70 million? You don't want to do that by hand.
Yes, I do.
For who? Yeah. You want a regular one? Yeah. Over in the brown box. No problemo. So, multiplying this one out with scientific notation, actually multiplying scientific notation is really easy. Here's what you do. And I'm sure you have done this in your science classes at some point, and you should know how to do this anyways. You multiply the two numbers out in front. 3 times 2 is 6. And then you do 10 times 10, and then you find the exponent by adding these two numbers. 7 plus 5 is 12. 6 times 10 to the 12. So it's a 6 followed by 12 zeros. See what I mean about scientific notation is all about really big numbers. Or if we have negative exponents, really small numbers.
not multiply the tens?
No, you do not multiply the tens, you just add the exponents. That's, like I said, I love scientific notation. For this kind of stuff, it's actually fairly simple. So the next problem, same idea. I multiply the 6 times the 4, gives me 24. And then I add the exponents, times 10 to the what? Negative 2. But I have a problem with this answer.
Negative.
No, it's not that. That's not my problem. Scientific notation, negative exponents are great. It just means it's a small number instead of a big number. Does anybody know what my problem is? What? Nope.
Wait, what? The negative?
There you go. Bingo. That's it. We're not allowed to have 2-digit number up in the front. No. Nice try.
Wait,
Yeah.
2 digits.
That's a good one. That's a good one. I got to admit, that's a good one. You're not allowed to have a number larger than 10. So what you have to do is you have to move the decimal place. So my decimal place is normally here, right? Now I need to move it here. So I'm going to have 2.4 times 10. But here's the other thing. If I change the decimal point here, I have to change the exponent. And it's a very easy rule.
Even.
Did I make this number smaller or bigger when I changed it? I made it smaller. If I make this number smaller, I make this number bigger. So I moved it over 1, I add 1. So that's 10 to the negative 1. Because negative 2 plus 1 is negative 1. If I had a number that was smaller than 1, I would need to move the decimal place to make it bigger than 1. If I make the number bigger, I make the exponent smaller. The exponent goes in the opposite direction of what my number in front does.
Oh, sorry.
So
Why would you ever need to make it big?
if you multiplied, let's say, for example, I ended up, and it generally doesn't happen very often. It happens more with division. But let's say I ended up with like 0.12 times 10 to the 5th. I'm not allowed to have 0.12. I have to have at least one number in front of the decimal, but no more than one number in front of the decimal. So I would have to move this over, which means I have to change that as well. It doesn't happen with multiplication, but it does happen if we do division. So we might have that if we do division. Yeah, good question, though. Like I said, I love scientific notation. Really, really big things. Distances between planets and stars and crap like that. Or really small things. How heavy is an atom and the parts of an atom? That's what scientific notation is all about. Because we're talking about how big a bird is, and how, so you don't need scientific notation for that. You need it for atomic scale and planetary scale. That's what you need it for. Any questions? Okay. Hey.